Hello, welcome back to Kian's Academy. Today we will be talking about an ellipse, the derivation of the standard form, and a sample word problem. This is an example of an ellipse. An ellipse is defined as the set of all points whose sum from 2 points, the foci, is a constant number which is denoted by 2a. An ellipse has the following parameters. It has foci and 2 vertex and 2 co-vertices. The distance from the center to any of the foci is denoted by C. The distance from the center to any of the vertices is denoted by A. The distance from the center to the co-vertices is denoted by B. This line is the major axis. It passes through the vertices and the foci and the center. This is the minor axis. It passes through both of the co-vertices and the center. If we rearrange ABC into a right triangle formation, using the Pythagorean theorem, this relationship can be represented by a squared is equal to c squared plus b squared because it forms a right triangle. Let us proceed to the derivation of the standard form. For example, we have an ellipse that has an arbitrary point P with coordinates x and y. By definition, the distance between P and f of 1 plus the distance between P and f of 2 should be equal to 2a. Using that basis, we can derive the standard form. Our coordinate for P is xy. Our coordinate for f of 1 is negative c, 0. And our coordinate for f of 2 is c, 0. Distance 1 is P to f of 1 and P to f of 2. Using the distance formula, we can put that measurement in the equation. The square root of x minus negative c squared plus y squared plus the square root of x minus c squared plus y squared equals 2a. This will become positive. We can just simplify y squared. We can also simplify to y squared. We transpose this radicand to the right side of the equation, becoming negative. We must square both sides in order to cancel the radicand. Squaring both sides, square the first, 2 times the first and the last, and square the last. It will arrive to simply this equation equals the square of 2a is 4a squared. 2 times 2a, 4a times the square root of quantity x minus c squared plus y squared, plus we cancel the radical, leaving us with the quantity x minus c squared plus y squared. We expand the squares. Square the first, 2 times the first and the last, square the last, x squared plus 2cx plus c squared. We also do that on the right side of the equation. Square the first, 2 times the first and the last, square the last, x squared minus 2cx plus c squared. We cancel what we can, c squared, y squared, and x squared, c squared, and y squared. It leaves us with 4cx because the negative 2cx has been transposed to the left side of the equation, becoming 4cx. Since all of them have 4, we can simplify the equation into cx equals a squared minus a square root x minus c squared, because 4 can be cancelled throughout. We transpose a squared to the left side in order to isolate this certain term. We square both sides. C squared x squared minus 2a squared cx plus a to the fourth. Square the first term. Negative a squared is a squared, and we cancel out the radicand. X squared minus 2cx plus c squared plus y squared. We distribute a squared throughout the right side of the equation, becoming a squared x squared minus 2a squared cx plus a squared cx plus a squared y squared. We cancel out negative 2a squared cx, leaving us with c squared x squared plus a to the fourth equals a squared x squared plus a squared c squared plus a squared y squared. Remember the relationship between a, b, and c? Now, using that, we can derive a formula. We substitute c squared throughout with a squared minus b squared. We put this value in here and also in here, leaving us with x squared times a squared minus b squared, and here a squared times the quantity a squared minus b squared. We distribute x squared, a squared x squared minus b squared x squared. We distribute a squared, a to the fourth minus b squared a squared. We cancel what we can, a squared x squared and a to the fourth, leaving us with negative b squared x squared equals negative b squared a squared plus a squared y squared. Since the standard form requires us to equate to 1, we divide throughout by b squared a squared after transposing b squared a squared to the left and negative b squared x squared to the right. We divide all throughout by b squared a squared. B squared will be cancelled, a squared will also be cancelled, leaving us with 1 is equal to x squared divided by a squared plus y squared divided by b squared. This is the standard form of an ellipse. Using that standard form, we can apply it to many problems. Here is a sample word problem. The arch of a bridge is a semi-ellipse with a horizontal major axis. The span is 60 feet and the top of the arch is 20 feet above the center of the ellipse. A horizontal roadway is 4 feet above the arch. Find the standard form of the ellipse. B. Find the location of the foci with relation to the center of the ellipse. C. Find the height of the roadway from the arch 15 feet away, from the center of the ellipse. Round off to the nearest hundred. First, let us find the standard form of the ellipse. This problem can be illustrated by an arch and a roadway 4 feet above the very top of the arch. The span is 60 feet, which means this one is 2a. We needed to find a. Divide both sides by 2. A equals 30. B is already given in terms of 20. We just substitute a and b to the standard form of an ellipse. 30 squared will become 900 and 20 squared will become 400. This is all that is asked in question A. B. Find the location of the foci with relation to the center of the ellipse. Since we already have A and B, using the relationship between A, B, and C, we can derive a formula for C. We transpose b to the other side, a squared minus b squared, and extract the square root in order to get plane C. We substitute a here and b here. 30 squared is equal to 900. 20 squared minus 20 squared is equal to 400. 900 minus 400 is equal to 500. C is equal to the square root of 500 equals to 10 square root of 5 or approximately 22.36. So it means that the foci, the two focus, is 22.36 feet away from the center. Finally, find the height of the roadway from the arch 15 feet from the center of the ellipse. It is asked the distance from this point to this point. In order to get that, we first need to find this distance and subtract it from the overall distance. We first get y. Using the standard form and x, let x be 15. 15 squared is 225 divided by 900 is equal to 1/4. Transpose 1/4, 1 minus 1/4 is 3/4. Apply cross multiplication, 400 times 3/4 is 300. Extract the square root, y equals 10 square root of 3. So we know the height from the arch to the major axis at 15 feet away from the center. Now, in order to get this distance, we just need to subtract 10 square root of 3 from the 24 feet, the combined height of the arch and the roadway. 24 minus 10 square root of 3 is approximately 6.68 feet. So it means that the height from the roadway from the arch is 6.68 feet. Thank you very much, and always listen to Sir Edward in your lessons.